And finally, we come to question 2.6. Brown enamel of the teeth is a sex-linked trait or characteristic. A dominant allele on the X chromosome causes brown teeth in humans. So our first question says, explain why more males than females have white teeth. Remember that if we have, sorry, Adelaide, I need to stop you there. Is this supposed to be brown? Does it say white? And can you just read the question? Is the question a dominant allele, not a recessive allele? This is an unusual one. A dominant allele causes brown teeth. Explain why more males than females have white teeth. That should be brown teeth.
Is it?
Yeah. Explain why more. Have we got the
Memo?
The memo. What does the memo say? Two 2.6.
0.1, right?
Yeah. Okay, males only have one X and one Y. And that doesn't have the allele. In order to inherit one recessive allele to have white teeth. Whereas females have two X chromosomes, so they'll inherit two recessive alleles. So they have to inherit. It's a very strange way of doing it. Okay, all right.
Do you maybe want to keep this with you here?
No, it's fine. I see the way they're going there.
Oh,
It's a very strange way. Can we start off with 2.6 again?
Okay, should I leave this here?
No, it's fine. You can take it.
Okay.
Let's look at question 2.6. Brown enamel of the teeth is a sex-linked trait. A dominant allele on the X chromosome, and that's why we see it's a sex-linked trait, causes brown teeth in humans. So it's a dominant allele on the X chromosome. If you had the recessive allele, it's going to code for white teeth. So our first question says, explain why more males than females have white teeth. So in order for a male to have white teeth, he's got to have the recessive allele. In a female that has two recessive alleles, she will have automatically white teeth. But as soon as she has one of those alleles that has the brown-toothed allele, she's going to have brown teeth. And if she has brown, she will also have brown teeth. And that is why, because it's a dominant allele, the woman needs to have small b in order to have white teeth. As soon as she has one capital B allele, she will have brown teeth. When she has two brown alleles, automatically brown teeth. Whereas this male will have white teeth. This male will have brown teeth. And so more males than females have white teeth. We're looking here at half of males will have white teeth, whereas only 1/3 of females will have white teeth. Now let's look at our genetic cross. A man with brown teeth, we know that his genotype has to be XBY. married a woman with white teeth, and she has little b, because she's got white teeth. Use a genetic cross to show the possible phenotypic ratios of their children. And we're using XB for brown teeth, Xb for white teeth. So what you have to do there, I'm just getting a little bit of space for us to do this cross. What you are going to have to do there is you're going to have to say the parental 1 generation has our brown-toothed man crossed with our white-toothed mother. That is the genotype. And saying that it's brown-toothed and white-toothed, that is the phenotype. Now we can put them into a Punnett diagram. And in the top row or the first column, we segregate the alleles, as if we were looking at meiosis, the products of meiosis. And we say, if we do the female over here, XB, Xb, and the male, XB, Y. Now in the body of the table, we show all our possible recombinations as a result of fertilization. Write this down for your marker so that your marker knows that you know what's happening in the top row and what's happening in the first column, and that you know what's happening here in the body of the table. XB, Xb. Same thing. XB, Xb. This is going to be Xby, and this one is going to be Xby. So our filial generation is going to look like this. The genotype of the first filial generation is going to be 2 capital X, capital B, capital X, small b, to 2 X little b, Y. We're asked to show the possible phenotypic ratios of their children. So we've got to take this genotypic analysis and we've got to change it into the phenotype. We know that these offspring are going to be females and they're going to have brown teeth. And we can simplify our ratio. 1 female with brown teeth and compared to 1 male that's going to have white teeth. 1 male with white teeth. And that is the answer to this question. 6 marks. You're going to get marks for showing the phenotype and genotype of parents. You're going to get a mark for showing segregation of alleles. Marks for filling up the body of the table. Marks for getting the genotype out of the table and then answering the question, what is the phenotypic ratio? That is going to give you your final set of marks. And that brings us to the end of question 2.